Jintao Xu from Peking University, China. I'm the director of EfD China. And today I'm very delighted to introduce our new speaker, Professor Xiaoguang Chen. Professor Chen is a professor at the Southwestern University of Finance and Economics. He earned his bachelor's, master's, and PhD degrees from Peking University, the Chinese Academy of Sciences, and the University of Illinois at Urbana-Champaign, respectively. His research focuses on the interactions between environmental, agriculture, and management issues. His work has been published in leading science, economics, and management journals, including Nature, GEM, AJAE, and Transportation Science. He has been funded by China National Natural Science Foundation, as well as the World Bank. Today, he will speak about how financial management facilitates farmers' adaptation to air pollution in China. Xiaoguang, you have in total about 1 hour. You probably can speak about 45 minutes. Then we will leave some 10 to 15 minutes for Q&A. So Xiaoguang, you have the floor.
Okay, thank you, Professor Xu, for the kind introduction. Actually, I studied with Professor Xu from 2003 to 2006. Basically, what I have is what he taught me, in roughly 20 years ago. So he trained me. Let me share my screen with you. Can you see my screen?
Yes, we can.
Okay. Okay. So basically, this paper is a joint work with my current PhD student, Xiaoguang, and a colleague at Hong Kong University of Science and Technology, Guangzhou, and also my PhD advisor, Marco Kana, and that's myself. Currently, I'm based in Chengdu, China. So here is the rough the outline of my talk. First, I will introduce the background information of the paper. Then I will go through the data, methodology, and results. So probably you already know that in China over the past 10 to 15 years, there is a significant reduction in major air pollutants. If you look at the figure on the left, you can see the PM 2.5 concentrations have declined by roughly 50%. SO2 declined by 75%, and NO2 also declined substantially. But over the same period of time, ground level ozone concentrations have increased very substantially, by 42%, in 2022 relative to the level in 2013. Now there is a big increase in ozone pollution concentrations. So the map on the right-hand side is the spatial distribution of ozone pollution. You can see most of the ozone pollution actually occurred in the east and central parts of the country, right? So which is also the major agricultural production region in China. If we look at the literature, we know there are a lot of papers that have examined how air pollution affects a bunch of socioeconomic indicators. In the context of agriculture, a lot of papers have looked at how crop yields, labor productivity, and also overall agricultural productivity. That's agricultural TFP responded to rising air pollution levels. So those studies actually are very abundant. So basically, this strand of literature shows that the decline in productivity mostly occurred due to air pollution. As a result, the decline in productivity is likely to reduce the total agricultural output. Therefore, household income is also likely to be negatively affected. Therefore, air pollution is likely to pose significant threats to both agricultural sustainability and also the rural household welfare. So based on the previous slide, we can tell that there are several understudied areas. The first area is although we know pollution can significantly reduce agricultural productivity, but we do not know to what extent air pollution is going to affect farm income, also the consumption of farmers. Also, we don't know what that implies for rural household welfare. Okay, that's the first area that is understudied. The second area is we do not know very well about how rural households adapt to air pollution and what kind of strategies they can use to cope with air pollution. Okay, so that's second area. The third area is whether household financial management can be an effective tool in coping with air pollution. Okay, so that's three understudied areas. So basically in this paper, those are the questions we are trying to address. First, we want to look at how air pollution affects agricultural productivity, in China, and to what extent the productivity loss can be translated into the reductions in household income. Secondly, we want to examine whether and how farmers adapt to air pollution. Okay, that's the second question. Thirdly, we want to look at whether household financial management can play an important role in helping farmers to cope with air pollution or adapt to air pollution. Okay, that's three research questions we want to address. The data part, we have very detailed household level data, so collected from China Household Financial Survey. Basically, this survey was initiated roughly 10 years ago in I think 2012 or 2013, and we have three waves of the data, including agricultural production. So in total, we have roughly 30,000 rural households in our data set, covering about 370 rural counties. And the information is also rich. It includes detailed production inputs like labor, cropland, and other inputs as well. It also includes output values, farm income, and farm consumption, and also farmers' financial assets. So we collect very detailed information on pollution and weather from ground-based monitoring stations. In total, we have 1,600 pollution monitoring stations, and for weather station, we have roughly 840 stations. And the econometric model is very simple. We use a fixed effect model to look at how pollution affects a bunch of agricultural outcome variables. So on the left-hand side, we have household information for household I in county C, province S, and year T. on the right-hand side, we mainly focus on ozone pollution. So we use different, measures, different indicators to measure ozone pollution. So I will introduce those measurements later in later slides. In addition to pollution variable, we control for weather variables, including temperature, precipitation, sunshine, wind, and humidity, and others. We include both linear and quadratic terms of these weather variables. And we also control for a rich set of fixed effects like household fixed effects and the province by year fixed effects. TFE measurements. So basically, we use a Cobb-Douglas production function with household fixed effect to estimate household level TFP. So this methodology is borrowed from this Cherry paper, published in 2021 in Review of Economic Studies. So we include, on the left-hand side, we have, total household production of agricultural products. So inputs, we consider labor, farmland, machinery, and other inputs, including fertilizer, seeds, and pesticides. So basically, the three terms here, these three terms together capture household level TFP, okay? And for ozone agriculture measurements, we have three measurements for ozone. The first measure is called AOT40. Basically, it accumulates ozone concentrations above 40 ppb. So those three measures are widely adopted in the agronomy literature. Okay. So the second ozone variable is called SUM06. So the only difference between AOT40 and SUM06 is the threshold for ozone. So for SUM06, it accumulates ozone concentrations only when its concentration above 60 ppb. And W126 is the measurement proposed by US EPA. And identification, so there is a very significant endogeneity problem in our equation 1 because air pollution is clearly not exogenous because there are a lot of factors that can make air pollution endogenous. So in order to address this potential endogeneity problem, we use wind direction as the instrumental variable to address this problem. So the idea is very simple. Although the equation 4 seems very complicated, but the idea behind this identification is very simple because wind direction can directly affect local pollution concentrations because wind can blow pollutions away, so it's directly affects pollution. So therefore, it satisfies the instrument relevance assumption. So for the exclusion restriction assumption is we think wind direction can affect pollution concentrations, but is not likely to directly affect agricultural outcome variables. For example, agricultural TLP is unlikely to be affected by wind direction, right? So the possibility is very, very low. So the only effect, so the only channel wind affects agricultural outcome variables is through its impact on air pollution. So it satisfies the exclusion restriction assumption. So here is the main finding. The first, we look at how air pollution, especially ozone pollution, affects agricultural productivity. We have two panels. In panel A, we consider pollution and weather variables over crop growing seasons. And in panel B, we consider pollution and weather over the entire year, because agriculture agriculture TLP may only capture productivity in the cropping sector. That's why we have two panels. So in both channels, we find there is a very clear association between AOT 40 and agricultural productivity. So let me introduce those 5 columns, okay? So in the first column is a simple OS regression, a simple OS. In column 2, in addition to ozone variable, we additionally incorporate weather variable like GDD, HDD, and other variables. And in column 3, we use IV approach to address the potential heterogeneity of AOT40. So that's IV estimates. And column 4 and 5, they are still IV estimates, but we use different approach to construct agricultural TLP. Okay, that's the difference between across different columns. So across different columns and the panel A and the panel B, we find that there is a significant association between AOT 40 and agricultural TLP, and the relationship is negative. You see, it's negative, right? So the basic finding is for each SD increase in AOT 40, agricultural TLP is going to decrease by 15 to 16%. So that's a very big impact. For HDD is called harming degree days. So for each SD increase in HDD, we find the TLP is going to decrease by 8%. So therefore, we can conclude that the negative impact on TLP due to ozone pollution is larger than the negative impact of high temperatures on TLP. Okay.
Sorry, Xiaoguang, can I ask a clarification question?
Sure.
Yes, so it's very simple. It's how your GDD and HDD is defined, because I mean China is very large from the north and the south, and the crops maybe, do they have the same kind of rules of, I mean, the temperature is like higher than 35 degrees, that must be harmful, right? Yeah, crops, yeah.
So I think for GDD, we consider the temperature range from 8 to 33 degrees Celsius. For HDD, we consider heat accumulated when temperature is above 33 degrees. We try different thresholds. Results remain very.
Oh, okay,
also,
thank you. So that's the same across the entire country, right?
Yeah. Yes.
Oh.
Okay, I will continue. The next, we want to look at whether the decline in productivity has been translated into the reductions in agricultural output, also farmers' income. So basically, what we find is for each SD increase in AOT 40, farmers' total agricultural output value decreases by 15%. And the farmers' total sales revenue and total disposable income decreases by roughly 14%. Here you see there are a lot of colors. So B means baseline results, and from R1 to R18 we consider 18 different robustness checks, so which will be discussed later. So cross all different scenarios, we see the results are fairly robust. The impact on agriculture output value is negative and roughly range between, I would say, 10 to 15%. Also for the sales revenue, the impact on sales revenue is also negative. Total income also declines. Okay. So there are log outcomes and IHS outcomes because there are some zeros in observations. So therefore, we use IHS transformation to deal with zero observations with zero values. Okay, so they are also consistent. Next, we want to quantify the historical losses due to ozone pollution. So basically, we want to quantify to what extent rising ground level ozone has reduced agricultural TLP, agricultural output, sales revenue, and farmers' income over a sample period. So when doing this, we consider a control factor scenario, so where we assume ozone pollution is held at the 2013 level. If ozone pollution is held at the 2013 level, we can predict, based on the regression results, we can predict what TLP level would be, right? Then we compare the observed, the TLP value in 2014 with predicted value when ozone concentration is held at the 2013 level. So the difference is because of ozone pollution. Okay, so through this counterfactual analysis, we find that if ozone level is kept at the 2013 level, agricultural TLP would have been 12% higher in 2014 and would be 70% higher in 2018. So similarly, agricultural output, sales revenue, and total farm income would be much higher if ozone level is maintained at the 2013 level. Okay, so that's historical losses due to ozone pollution. So next, we want to look at whether ozone pollution has affected farmers' consumption, because it's reduced farm productivity and farmers' income. Naturally, one would think that it will have a negative consequences on farmers' consumption because the income decline. So we consider several consumption categories, including food, clothing, housing, and others. And we also consider two transformations for those variables because some households report zero values for these consumption categories. So through all of this, we find there is no clear reduction in consumption, which is puzzling, right? Which is very puzzling. So then we continue to explore whether farmers take any actions to cope with the decline in income. So when doing that, we consider several financial behaviors of rural farmers. We consider cash holdings, current deposits, fixed deposits, and production loans and the consumption loans. Okay, those are 5 financial indicators of Chinese farmers reported in the data set. And again, we consider different transformation for these variables. We have log outcomes, which capture intensive margin responses, and 0-1 outcomes, which capture extensive margin responses. And IHS outcomes captured both, the combination of intensive and extensive margin responses. Through a simple regression analysis, we find that rising ozone pollution has significantly reduced farmers' available cash holdings. You see their cash holdings reduced by maybe roughly 2-3%. And meanwhile, it significantly increases production loans, right? Production loans. Also, ozone pollution reduces the likelihood of holding current and fixed deposits, right? So those are the main findings. So basically, through this analysis, we find farmers' financial behaviors did respond to rising ozone pollutions. Also, we find these responses actually are not homogeneous. It's depending on rural financial accessibility. So here, rural financial accessibility is defined by the number of formal financial institutions like banks, mostly banks, agricultural banks. So if a region has a reasonable number of financial institutions, that means they can easily get loans from the bank. Okay, so in these areas, they are more likely to get production loans. Okay, so the farmers are more likely to get production loans when their financial accessibility is high. So that, I think, makes intuitive sense. Then we want to study, what those production loans were used for, right? So they get loans, and maybe they use production loans to do some other stuff. We want to look at whether they use production loans to improve their production technology, or they purchase more productive inputs to enhance the agricultural resilience. Okay, so basically what we find is farmers use their loans to purchase agricultural inputs, particularly seed and pesticides, okay, to increase their productivity and increase their resilience against ozone pollution. So these purchasing behaviors are only observed in regions with a good financial accessibility. So in regions with very low financial accessibility, we do not observe this relationship. Okay. So as a result, we found that in regions with medium and high financial accessibility, their agricultural TLP is not significantly affected by ozone pollution. Okay, as a result, their agricultural output value is also not significantly affected, because better financial accessibility help farmers to mitigate the negative impacts of ozone pollution on TLP and output value, because they can use loans to purchase advanced inputs. Okay, but there is a cost for this type of adaptation. What we find is, in regions when farmers, get their production loans, so the channels are mixed. Some farmers can get loans from formal financial institutions like banks, but some other farmers may get their loans from friends and relatives and informal financial institutions. basically what we find is, farmers' loan interest rates increased by roughly, 5.8%. Their interest rates are very high, compared to the formal institution interest rates. And also their loan interest payments increased by roughly 20%. Okay, so that's the cost for adaptation. And we did a lot of robustness checks. We tried to use different, ozone metrics. Like I mentioned earlier, we use SUM 06, also W126, and also the average ozone concentrations. And we tried different model specifications, and we tried to use dynamic lag models and placebo tests, and we also tried to construct weather and pollution variables using different IDW methodologies. The results are pretty robust. In total, we have roughly 18 robustness checks. So that's the results. I'm not going to repeat. And let's play simple test results. So in conclusion, basically through this paper, what we find is ozone pollution has significantly reduced agricultural productivity, and also leading to a significant reduction in farm household income. And farmers use cash reserves and production loans to cope with air pollution. So that's what we call household financial management. Okay, so our policy implication is, probably we can integrate environmental governance with rural financial reform to increase agricultural resilience to cope with environmental changes. Okay, so that's all I have for this talk. Thank you very much for your attention. I can take some questions.
Hello, thank you for the great study and the presentation. Right, so in your discussion, you did mention that pollution can be endogenous, and you used the wind as an instrument, and your exclusion restriction is that the wind can only affect your outcome variable, which can include the agricultural output through the pollution. Yeah, but there are times whereby, depending on how strong the wind is, okay, and the type of crop in question, let's say maize or rice, okay, it might lead to, distortion in terms of reduction in productivity. So how do you account for this?
I agree with you. Every time I read the paper, I read that part, I think that's a problem. But here, so you have to keep in mind that the instrumental variable is the wind direction, not the wind speed. Okay, wind direction, not wind speed. So in the regression model, we control for wind direction. I think, we control for wind speed.
Control.
Okay.
It's control.
But did you observe?
But again, I agree with you. Wind direction may also directly affect, some of the agricultural outcome variables.
Is there no correlation between the direction and speed, the wind direction and speed?
No, there's no. It's not. It's a very significant correlation.
You are not correlated, right?
Yeah, no, I'm not correlated.
Okay. But you claim that the direction would affect the pollution, correlate with the pollution level.
Yeah, wind direction affects pollution.
Yes.
Wind direction probably is not highly correlated with wind speed.
Okay. Right. Thanks.
Were there any kind of a systematic pattern that wind from the north to south has systematically higher speed than wind from other directions? I think that was the question.
It does talk about the correlation, right?
Yeah.
I think depending on seasons, because there are two monsoon seasons. So I have a paper. So in that paper, basically, we are trying to identify the spatial spillover effects of air pollution. When working on that paper, I did some research. So there are two monsoon seasons. So in winter, wind basically blows from north to south, and in summer, wind blows from southeast to north. Okay, so therefore, I guess the wind speed probably is high in the north in winter, but in summer, probably wind is strong in the south. Okay, depending on seasons and depending on other factors, but I have not checked, whether wind speed and wind directions are highly correlated. I can do that.
I have one comment and two questions, if I may. The comment is that I found the conclusion that farmers' consumption remain stable, but savings and borrowing declined and borrowing increased. That's very interesting because if you reduce saving and increase borrowing, then it has two effects. So the money available for investment in the future is less if the effect is large enough. Then the second is the interest rate will go up, then further reduce investment in the future. So dynamically, it seems to be the air pollution affect agriculture, affect farmer even more because of this dynamic macroeconomic impacts. But yeah, only if the effect is large enough. My two questions is, number one, the formation of ozone is largely due to sunshine and the temperature. For same level of emission, without sufficient sunshine, without high temperature, ozone won't form. But even when there's good weather condition, suitable weather condition like sunshine, temperature combination, even very little emission will lead to very large ozone occurrence. So have you controlled? So it seems that ozone is highly related to sunshine and temperature. So I wonder if you have controlled these elements. The second question is that you indicate in your counterfactual analysis, you control ozone level at 2013. Then you found that all the productivity, yield, income increase, which means you indicate that ozone has been increasing over time. But China has claimed victory over like a battle against war against air pollution. So PM 2.5 reduced dramatically. Then why ozone increased during this period? So what's your, can you share some insight into that? Okay, that's all.
Okay, so for the first question, let me go back to the regression model. We did control for temperature and the sunshine hours, in the regression. So in the first column, we only, include ozone variables, and in the second regression, we include, weather variables. Basically, we try to, examine whether, including weather variables can make any difference. But from this analysis, you can see, it did, cause some changes in estimated ozone impact. So yeah, we did control for sunshine durations, and those GDD and HDD are basically temperature variables. So those are controlled. For the second question is, if you remember the background information, we find there is a significant increase in ozone concentration. So that's information based on the ground level monitoring stations. So that's ground monitored ozone concentration. That's has been increased very significantly over the past 10 years. But it's actually very puzzling. Why PM 2.5 decreased, but ozone levels increase. I think there are probably two possible explanations. First, these two variables are negatively correlated. If you look at any papers, if they have a correlation table for different pollutant variables, you can see ozone and PM 2.5 are negatively correlated. So if one variable decreases, another one is likely to increase. So if PM 2.5 level decreases, that means visibility is likely to increase. Also, the sunshine and also the solar radiation reaching the surface is likely to increase, right? Reaching the ground surface is likely to increase. Therefore, helping the formation of ozone concentrations, right? So I think that's the first explanation. Secondly, I think the reason is because the Chinese government pays too much attention to PM 2.5, NO2, and SO2, so they ignore ozone pollution. Probably in some industries, emitting VOC and NOx may significantly increase their production levels, and therefore the emissions also increase very significantly, causing the large rise in ozone concentrations over the past 10 years. So that's my guess.
Thank you.
Thank you for a great presentation and a very nice paper. I mean, but as some of my colleagues were asking about the instrumental variable, and this is kind of the common thing when we do instrumental variables, that is kind of one of the things that stuck to our minds. But I was wondering, I mean, you already said that you have some concerns about the wind, and I was thinking, in addition to the wind speed that you are controlling for, but I was also thinking about this possibility of a wind direction affecting some cross-pollination and pollination of some of the crops. No? So I don't know if there is a way to somehow isolate that effect. No, I mean, I really don't know anything about China agriculture, but just if you could say, if we have these crops that might be subject to this cross-pollination and where that might matter, if we exclude them, we still find the effect, no? From the region where this is more common. I mean, something just to go in that direction of saying, yeah, it could be possible that there is some wind effect through pollination, but we are excluding it because of this way to control for it. So will anything like that make sense?
Yeah, I like your comment. So so basically, because we have too many air pollution variables, in addition to ozone, actually in one of the robust checks, we also controlled for PM 2.5, SO2 and others. So therefore, that means we need multiple instruments instead of only one instrument. So the beauty of using wind direction as instruments is that it can, generate a lot of instruments depending on wind direction, because we can split the wind direction into different angles. Okay, so that generates a lot of a large number of instruments. So basically, this idea is borrowed from one of the papers published in American Economic Review. They use wind direction as instrument to look at how PM 2.5 affects human health. So that's the 2019 AER paper. In addition to wind direction, actually we also used thermal I forgot the name. It's called the difference. The difference between temperatures. I forgot the name of the term. So anyway, we try to use different instrumental variables, to examine the robustness of our findings. So basically, what we find is, it doesn't make any too much difference. Wind direction is good, in this case, to as the instrumental variable. Okay, so the name is called thermal inversion. Thermal inversion. So that's a also popular, instrument in when studying the air pollution impacts.
Yeah, so Xiaoguang, I have an additional question on the channels that ozone affect agricultural production, and then so that access to finance could help the input investment or something. Yeah, so the adaptation analysis part. So kind of the channels, I think, I don't know, I'm not an expert on that. So kind of ozone affect agricultural production through photosynthesis. And then it reduces the yields of crops. So because the findings are the accessibility increases their input on seed and the fertilizer. So yeah, maybe you can explain more on that, how the story is, yeah, is behind that findings.
Okay, actually we have a paper, published last year. So in that paper, that's the paper, this one, published in PNAS Nexus. So in that paper, we tried to examine how ozone pollution affects agricultural productivity in China. But the study was based on the county level analysis, unlike this one. The current paper, use household level data to construct agricultural productivity. But for the PNS Nexus paper, we use county level information to construct the agricultural TLP. So there are several possible channels by which ozone pollution can affect agricultural TLP. So firstly, as you said, ozone has a very negative impact on crop yields. So that's the well-established fact by the agronomy literature. So because it can significantly affect, grassland, also forest, therefore, livestock that heavily rely on grazing will also be negatively affected. So that means, livestock productivity will be affected by ozone pollution. Also, ozone pollution can affect human health, right? Can affect human health. There's also a large medical literature, documenting that. So also, for example, this one, there's an AR paper in 2012. They also found, ozone pollution can reduce. That's agricultural worker productivity. So combined, all those evidence suggests that ozone pollution can affect agricultural TFT. So that's something we already know. So in terms of the adaptation part, so we find is, farmers use their production loans to purchase, advanced inputs like pesticides and also improved seeds to increase their agricultural productivity. I think that's not the very direct evidence, but somehow it helps to explain why agricultural productivity in those regions were not negatively affected, because farmers in those regions did something.
Okay, so that's kind of the story that intuitively farmers realized the reduction in production, and then so like use advanced seeds and more pesticides, just like simultaneously or intuitively to increase the yields. But of course, they are not scientists, so they didn't know that the ozone reduces yields because of influences on photosynthesis. So yeah, actually they don't know how to solve the problem. Yeah, so it's kind of very kind of intuitive reaction on reduced yields. Yeah. Okay.
I like your comment. Actually, we sent the paper to PNAS in March. We had two reviewers. They sent the paper out for review. We had two reviewers. One reviewer liked the paper, and another reviewer, had the problem, with the adaptation part.
Yeah.
That's what we discussed. That reviewer did not buy our story. Now we are trying to revise this paper to provide evidence that farmers actually did something to increase agricultural resilience. So that's the main comment from the negative reviewer.
Okay.
So hopefully, after incorporating all the comments from our discussion, we can get the paper out of my way.
Good luck. Do you guys have questions?
Not really, but with the wind that he says that with the wind that you said it only affect outcomes through pollution. Wind could affect agricultural outcomes without necessarily mean pollution. So can you explain that, because you said that wind can only affect outcomes only via pollution, because with agricultural output, depending on the crops that you are producing, the intensity of the wind could
destroy the agricultural outcomes when they are bearing fruits, or some could fall down depending on the intensity or the speed of the wind. So if you are saying that wind could affect outcome only via pollution, if you can explain it better then.
Yeah, I agree. No, it's totally depending on the type of crops grown in different regions. If in one region crops are very sensitive to wind speed and wind direction, then you're right. Wind direction may not be a valid instrument in that particular area. So I think we need to try. We can. I'm thinking to split the sample into different regions to see whether that's the case. So yeah, we can do that. I agree with you.
Okay.
Okay, yeah. I think that's about time, right?
Yeah. So before we close, we noticed that the Kanishka sent an online chat. Yes, maybe you can reflect on that, but I think maybe it's positive. His question is that, do I have this macroeconomic implication right? Reduce the savings and increase the borrowing creates compounding effects over time, meaning less money available for future investment plus higher interest rates from increased borrowing, reducing future agricultural investment. That's Jintao's comment on that.
Comment, yeah.
So thank you, Kanishka. So maybe maybe Jintao is busy with some other stuff. Jintao, would you like to say something?
No, I think it's a great, very interesting study, and probably Xiaoguang in the future can look to the mechanism between ozone level and the productivity. I don't know. I have another paper looking at co-exposure of PM 2.5 and ozone, and I don't really have knowledge about the linkage between ozone exposure and agricultural productivity. And Kanishka just point out some possibilities. Probably in the future, that will be an area to look at. And overall, it's a great work, and my congratulations.
Thank you. We worked on this paper for several years, and I spent one day to get the slide ready because I forgot the presentation this evening. Yuan Yuan just reminded me yesterday.
Thank you. So, am I done as a chair?
Yeah, thank you very much for the presentation and the seminar. Thanks, Jintao.
Thank you for having me.
Have a nice day.
Hope to see you soon in Tanzania.
Tanzania,
See you in Tanzania.
Bye.
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 Bye, thanks.
Bye-bye.